All right, it's time for AP Statistics with Mr. Walton. Chapter 6, Section 2, Transforming and Combining Random Variables. Here are the rules. I know you might have seen these before, but just thought it might be worthwhile to let you see them again. Here they are for the means, or for the mean. And here we are for the standard deviation. Of course, you can pause, you can look over, you can take notes so that you can come in and ask questions. Yes. And example number 1. Students in Mr. Walton's AP Statistics classes are expected to check their homework in groups of 4 at the beginning of class each day. You can read the rest. I've given you an outline, means, and standard deviations for Caroline, Kyle, Ryan, and Hannah. There we go. You look at that. What question is being asked? Here we go. If each student checks homework one after another, what are the mean and standard deviation for the total time? That's the key, the total time. That means each of these kids gets combined together. Let's use red to be consistent. Here we go. So that's equal to the mean of Caroline plus the mean of Kyle plus the mean of Ryan plus the mean of Hannah. I'm hoping you guys get 4.5 minutes. Now, when we calculate the standard deviation for all of them, let's say it's the total. Yeah, we'll go back and we'll change that x to a t. That's fine and dandy. All right. For the total, please remember these are variances for Caroline, the variance for Kyle, the variance for Ryan, and the variance for Hannah. So I need to take those standard deviations, square them, find the sum of them, and then take the square root, and hopefully you get 1.14 minutes. All right. So we're going to switch into a little bit of a nice maroonish purple. Okay. Suppose Caroline and Hannah decide to race and see who can check homework fastest. What are the mean and standard deviation for the difference in their times? Okay, so now we're looking for the mean of Hannah minus Caroline. So that's just the mean of Hannah minus the mean of Caroline. And hopefully you guys get that negative 0.4 minutes. Now, standard deviation, however, does it matter if we're subtracting? No, we always combine the variances by addition. Thank you. Thank you very much. And hopefully when you do this, you get 0.707 minutes. Can you talk about the mean and standard deviation in context? If you can, awesome. If not, practice now. Example number 2. Pulling in from the social studies department, Mr. Keenest and Miss Hanson are avid video game golfers. You guys keep reading. Okay, so for part A, since Mr. Keenest and Miss Hanson play independently of each other, keyword there, find the mean and standard deviation of the difference of their times. You try it now, they'll pop up in just a moment. All right, hopefully you got these numbers, or remember you could have used Hanson minus Keenest and gotten negative 10 minutes. Either is appropriate. Your standard deviation will be the same as mine. For part B, your favorite type of question, find the probability that Mr. Keenest will finish his game before Miss Hanson on any given day. Now remember, this is where we're looking at the combined, so I think a picture would be helpful. Right? We're talking about a mean of 10. We're talking about when does Miss Hanson score higher than Mr. Keenest. So we want our overall x, the combination of them, to be less than 0. So we're looking at here. 0. Okay? We use our normal CDF. We might want to define this as Keenest minus Hanson. That would help us out, right? And if we use that, we should get 0.2174. And I'm done? Not. write about this probability in context. On a randomly selected day, I believe that Mr. Keenest has about a 22% chance of finishing before Miss Hanson. All right. Keep in mind, we want to practice with those means and standard deviations. Am I talking about individuals and changing each variable, or am I talking about combining? Okay, here we go. We're done.